Athlete monitoring is essential in high-performance sports. It helps coaches, sports scientists, and athletes make informed decisions to optimize performance while minimizing injury risk. In this video, we'll break down the athlete monitoring cycle by Tim Gabbett and colleagues, providing a summary of the 4 key steps that guide training adjustments based on data. Firstly, Step 1, external workload, represents the total training load an athlete performs. This can include measuring total distance covered, the number of sprints completed, or the total weight lifted in a gym session. Tracking this workload provides objective data on how much work an athlete is doing. Moving on to Step 2, internal workload. This measures how the athlete's body responds to the workload, using markers such as heart rate responses, for example, time in heart rate zones or heart rate variability, perceived exertion scores, or lactate threshold testing. Monitoring internal workload ensures training can be tailored to individual needs, as not all athletes respond the same to the same training load. Moving on to Step 3, perceptual well-being. This looks at how the athlete is coping with the load. Are they reporting high energy and motivation, or do they feel sluggish and mentally fatigued? Perceptual well-being can be assessed using self-reported questionnaires on sleep, mood, soreness and stress, for example. Understanding these factors helps determine whether adjustments to training or recovery are needed. And last but not least, Step 4, readiness. Is the athlete prepared to train or compete? This step determines if an athlete is physically and mentally prepared for performance. Objective markers may include short, for example between 3 to 6 seconds, max effort cycle tests, counter movement jump scores, or heart rate recovery tests. Combining perceptual well-being scores with these objective measures provides a complete picture of readiness. Based on this data, coaches may decide to increase training load, maintain intensity, or schedule extra recovery. To support decision-making, Tim Gabbett and colleagues provide 3 key matrices to help interpret the data each step of the cycle. Let's take a closer look. Comparing external workload, what the athlete did, with internal workload, how they responded, helps identify training adaptations and risks. If external workload is high, but internal workload remains low, the athlete is adapting well and can continue to train at this level. If external workload is high and internal workload is also high, the athlete may be at risk of overtraining, so training intensity may need to be reduced. If external workload is low but internal workload is high, it may indicate maladaptation or fatigue, requiring further investigation. If both external and internal workload are low, an increase in training load may be necessary to stimulate adaptation. Combining measures of workload with perceptual well-being scores helps determine if an athlete is tolerating training effectively. If workload is high and well-being is good, the athlete can continue training or competing at this intensity. If workload is high but well-being is poor, adjustments may be needed, which may involve reducing training intensity. If workload is low but well-being is poor, external stressors or non-training factors, such as illness or personal stress, may be affecting the athlete's recovery, which may require further investigation. If workload is low and well-being is good, an increase in workload may be beneficial to enhance performance and adaptation. And moving on to perceptual well-being and readiness, if both readiness and well-being are good, the athlete is prepared to train or compete. If readiness is good but well-being is poor, mental preparation strategies, such as relaxation techniques or psychological support, may be needed. If readiness is poor, despite good well-being, additional physical preparation may be required before intense training or competition. If both readiness and well-being are poor, extra recovery should be prioritized before resuming training. Based on this matrix, athletes may need extra mental or physical preparation or additional recovery before their next training session. And that concludes this presentation on Tim Gabbett and colleagues' athlete monitoring cycle that was published in the British Journal of Sports Medicine, which provides a structured approach to decision-making in training, ensuring that adjustments are based on a combination of external and internal workload, perceptual well-being, and readiness to train. Tim Gabbett and colleagues also make the point that to maximise the effectiveness of monitoring, it's essential to educate athletes and coaches on its benefits and integrate both data and intuition into the decision-making process. If you'd like to read the full article, the link is in the description. As always, folks, thanks for watching. See you next time.